Hey class, today what we're going to do is talk about graphing lines, especially using a calculator to help you graph these lines. And this is kind of like a little exploration to help you identify slope, y-intercept, and kind of get the equations using a little bit of discovery and that kind of stuff. So first off, what we want to do is graph these three equations in our graphing calculator. So you want to grab your graphing calculator, go ahead and turn it on, clear everything that's in there, and then you're going to go to the y equals. That's up here in the top left. You're going to press that. If there's a stat plot on, you want to turn that off by going up, highlighting that, and hit enter, and it should go from being colored in black to not. And then what we want to do is, first one we want to press, for y1 we're going to press y equals x. So the variable button, the X button, is right there. Press the X. Then you're going to press graph. And if you notice, my window's a little bit messed up. So we like the zoom standard for that one. So you press zoom, and you go down to number 6, and it should graph that line. So that matches up with my line here. So now I'm going to graph my next one on the same axes by just going down 1, going to x plus 6. So I've got x plus 6, hit graph, and now you notice that I just graphed this line, and then you do the same thing, you get x minus 4. So we get those three things on there, press graph, and you now see that I have my three different lines that match up with these three things. So now I can look at them and kind of compare them on the same axes. So now we want to answer these questions. So what do you notice is the same? Now if you notice, all of them are parallel. They don't cross even if they went on forever. So if they're parallel, that means they have the same slope. So remember that last video we talked about the slope. That's the steepness of the line. The steepness of the line for all of these are the same. And if you notice, they're all going uphill from left to right. So that means that they're all positive slopes. So they all have the same positive slope. But what is different is where they cross this y-axis. And where they cross the y-axis is known as the y-intercept. So all of the y-intercepts are different. And I usually use this abbreviation for y-intercept a lot of times. So the difference is the y-intercept, the same as the slope. All right, so we look at our y-intercepts for each of these. My y-intercept for y equals x is 0. My y-intercept for x plus 6 is 6. And my y-intercept for x minus 4 is negative 4. So you should see a pattern of what's going on with these y-intercepts and what the equation should look like. So now let's write the similar equation for one where the y-intercept is at 5. So you should get y equals, we know our slope is x, and we're going at 5. So we want it to be up a little bit. So if we're going up, that's in the positive direction, so it's x plus 5. Here we got our y-intercept at negative 2. So we want to do y equals x, and then you're going to subtract 2 because we're moving down 2. So just like we had the subtraction there, so if it's y at y-intercept at y minus 2, we go x minus 2 there. All right. So that is for section 1. Section 2 is now talking about slope. So if you do the same thing, your y-intercept, you want to clear out everything except for probably your first one of y equals x. We'll just leave that one in there. So we're going to put 2x. I'm just going to go and graph all of these at the same time. 5x. 1 divided by 2x, 1 divided by 3x, and 1 divided by 4x. So now we actually have 6 graphs that we're going to look at. It's going to look a little bit crazy whenever you first start. So that's my line y equals x. That's the line y equals 2x. That's the line y equals 3x, or 5x, sorry. That's 1/2 x. That's 1/3 x, and that is 1/4 x. So if you notice, the first ones were getting steeper, whereas the second three were getting shallower. So if you notice our graphs, they're getting steeper and steeper and steeper as this coefficient of our x goes up, which is the slope. And as the slope gets closer and closer to 0, or our denominator gets bigger and bigger and bigger, our slopes get flatter and our lines get flatter and flatter and flatter and go more to the horizontal. So the same, if you notice all of these, I didn't add or subtract anything, so all of my y-intercepts are the same. But what is different is all of the slopes are different. All right, so now we look at what's the steepest. And so if you look at what's the steepest, is the bigger number is always going to be the steepest. So my line, my y equals 5x, that'll be the steepest. And then the shallowest one is going to be the one that's the closest to 0. So in that one, that's my line y equals 1/4 x. So that's the difference in all the slopes if you plug all those into your calculator. All right, for part 3, I'm going to do the same thing. I'm going to clear out everything in my calculator. And then plug in my line y equals x. And then my line, if you're looking for the negative, that's down here, negative x. All right, so we got that. So now what we're going to do, press graph. Notice that's my line y equals x. That's my line y equals negative x. So I graph those y equals x, y equals negative x. What is alike is their slopes are very similar, but their slopes are opposite. So this slope is negative, this slope is positive. So you can kind of think of the steepness is alike, but the direction is different. So this one's going uphill because my slope is positive. This one's going downhill because my slope is negative. We can also say that the y-intercepts are alike as well. And that would be the difference between a positive slope and a negative slope. So positive goes uphill, negative goes downhill from left to right. So if you're looking from left to right, uphill, from left to right, downhill. All right, so now looking at negative slopes, remember they're all going downhill from left to right. So we got negative x, negative 2x, negative 4x. So I get my calculator, clear out everything, put in y equals negative x, negative 2x, and then negative 4x. So have that in for my y equals, press graph. I get my line y equals negative x, y equals negative 2x, and y equals negative 4x. So if you notice, they keep getting steeper and steeper and steeper. So even though these numbers are getting smaller and smaller and smaller, you think of the absolute value of them are getting bigger, which makes the slope bigger, or makes the slope steeper. So what is alike is the y-intercept is alike because they're all going through 0, and then they all have a negative. Oh, we talked about the last one. Say direction is the same. But what is different is the steepness. So the direction is the same, but the steepness is different. And our steepest one is going to be the one with the biggest absolute value. Remember, the absolute value is the distance from 0. So this one has the biggest absolute value. All right, so that should be everything you need to know. Just looking at a glance at an equation, you should be able to realize everything about it. So how steep it is, where the y-intercept is, just by looking at the graph. So now we can start answering some questions. So where does each of these fall across the y-axis? So if you remember back to the very first one, it does not matter what the slope is. All we're worried about is that y-intercept. So this one crosses the y-axis at 7, this one's at 11, and that one's at 3. So that's where they cross the y-intercept. This one is which of these lines is the steepest. So you look solely at the slope, which is the coefficient in front of the x. So this is a 2, this is a negative 1, and this is a 1/2. Now remember, we're looking at the absolute value. So even if I had like a negative 4, if I had a negative 4x somewhere in here, that would be steeper than a positive 2. So you're looking at the absolute value. But positive 2, negative 1, 1/2. This one is going to be our steepest graph. And that is what we would answer for that one. So that is graphing lines in a nutshell. Remember, you can use your calculator. You want to do zoom standard first, and then if you can't see that, then you might want to zoom out. And that is it.